So let's continue our discussion on chemical bonding. We ended last session having this slide on here, and I started off with it again because of the importance of some of the terms that are being discussed here. First off, the bonding electrons that are involved are the ones that are being shared. The non-bonding electrons are the electrons that are not actively bonding or actively being shared. So it is important that we get these terms correctly and that we understand what we're all talking about. Now, some of the atoms, and why we bring this up, is that some of the atoms can form bonds with more than one atom. If we look at the unpaired valence electrons in a regular Lewis dot structure, we can kind of get an idea and see how many bonds it actually likes to form. So these may be, in fact, a way to figure out forming multiple bonds or bonds with more than one atom. For an example, if we write out the Lewis dot structure for, say, carbon, and if I have carbon written out, we will be able to see with its 4 valence electrons unpaired that it would like to bond 4 times. Now, how this bonding occurs can be with another carbon atom or with 4 different molecules. It can be with one other carbon atom too, and it all just kind of depends on how some things work. But ultimately, it will like to bond a total of 4 times. As we can see from these pictures here, chlorine and all group 17 elements will like to bond that total number of times, and that would be 1 time. Now, there are exceptions to these rules, but we're only going to worry about this for now. There will be other exceptions. Chlorine and all group 17. There are others that also like to bond only 1 time, such as, say, hydrogen. And when we look at, say, carbon, that would be and all group 14. Sulfur is also likes to bond 2 times because it has those 2 unpaired electrons, but also all group 16. And phosphorus has 3 unpaired electrons and will like to bond a total of 3 times, and like all group 15 elements will like to bond that many times. Now, as we go farther into this bonding, we will see more exceptions and more examples of some things that might vary and change a little bit. So this is just the early bonding that will happen. And this is a good start. Knowing the Lewis dot structures and being able to identify how many of those electrons are by themselves as an area of potential bonding that might occur. Now, again, there are some exceptions, but these are pretty good general rules. And that is the number of bonds everything likes to have will be based on the number of unpaired electrons, or electrons that are by themselves. The atom with the lowest electronegativity will like to be the central atom. Hydrogen, however, is never the central atom, and the one that is the least electronegative is going to be the one that is going to be a little bit farther to the left on the periodic table. Another rule of thumb can be looked at is the one that has more bonds or unpaired electrons. In another way, the one that can be bonded the more times. So the more bonds it can form, the more likely it is that that's going to be in the center, because then everything can kind of branch off of it. If there are several carbon atoms, they bond together first, then you add the other ones around it. And try to make things as symmetric as possible. It's not always going to be the case, and symmetry what does it look like is going to become through some practice and understanding how this works and why we have to draw things a certain way. Will become through more experience. And so the symmetry is something that we add at the very end of these guidelines, because that's something that will be added on as we begin talking about some other things. Now, there are four main steps in drawing a Lewis dot structure. Calculate the total number of valence electrons. That is the sum of each of the valence electrons for all of the atoms in the molecule. Divide that total number by 2. This will tell you how many pairs of electrons that you will have around the molecule. You first surround the central atom with 4 pairs, or 8 electrons, placing the remaining atoms around that central atom and in order of their identified. And that's usually going to be kind of from left to right, although finding that central atom is going to be the most important thing. Again, your central atom is going to be the one that will allow for more branches. And so that will allow them to have that octet rule, except for hydrogen, which really only will need 1. Now, these guidelines and these steps that we have here are good steps to follow, and they make more sense in the next slide when we actually put them into practice. So for some of these, we will start off with some of the more simpler ones and kind of go from there. And we'll see that I have carbon and hydrogen for the first one. I have what's called methane. I have 1 carbon atom and I have 4 hydrogen atoms. Carbon has a total of 4 valence electrons. Hydrogen has a total of 1 valence electron. And 1 times 4 is 4. 4 times 1 is also 4. We add those up and we see that we will need a total of 8. Divide that by 2 to get 4 pairs around my central atom. Well, that means that carbon is going to be my central atom. And therefore, I am going to put my Lewis dot structures around carbon. I'm going to then need to have my hydrogen. Well, I need to have 4 of them. Now, I'm using colors that will represent the ball and stick models that we use in the classrooms to allow us to kind of visually see where that comes from. And actually, the students' ball and stick models that we use in the classroom are usually white for hydrogen, but the larger ones are usually using yellow for hydrogen, so that's why I like to use the yellow. We can check ourselves here, and see that I have 1, 2, 3, 4, 5, 6, 7, 8 around my central atom, so it has its octet, and then every hydrogen also has just 2. So eureka, we've done that one correctly. So let's try another one. I'm going to piggyback off of the last one that I just did and see that I have 2 hydrogen and chlorine and 2 chlorine. Well, hydrogen again has 1 valence electron and chlorine is going to have 7. Now when we add these all up here, we can see that 2 plus 4 is 6. 6 plus 4 is 10. 20 divided by 2 will give us a total of 24. I'm sorry, not 20. Where's my math at today? But 10 pairs. Carbon is my central atom because it can bond the most. I will put the Lewis dot structure, carbon there. I can place 2 hydrogen symmetrically around there. I will also then be able to place 2 chlorine in those 2 spots. I place my hydrogen with my hydrogen bonding. I will place my chlorine around there. And now I look at it and say, well, I'm really short on the number of pairs that I have. Well, I forgot that I still have my non-bonding pairs of chlorine to add in. Now, sometimes what I have found students to do and be helpful is to actually write out the Lewis dot structures for the elements that they're bonding so that they have an idea of what they're going to look like by themselves and kind of put them together in that way. And so it's a way to kind of help put things together. We can see here that where the bonding is occurring, where's being shared, and so on and so forth. I can then count and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pairs just like I'm supposed to. Now the next one, for me, I always say is a matter of life and death. Because if we don't draw out water correctly, life doesn't exist. And so it's an important one. And so we have oxygen. The Lewis dot structure for oxygen would look something like that. If I place my hydrogen in the correct locations, I get water to look like that. And that's what water is going to look like as well. Water does not look like one of these things, and this is what usually bothers me, is that water does not look like that. If water looked like this, life would not exist. So we get rid of it. Now, the next one here is an interesting one in that we have some weird things happening. So let's take a look at it a little closer. I have nitrogen, two of those. Nitrogen likes to go 5. Oxygen has 4 of those and has 6. Is equal to 10. 4 times 6 is 24. 34 divided by 2 gives us 17. Now that's a weird number, but let's just see what we got going on. We will have our nitrogen. The Lewis dot structure for nitrogen, I'll just kind of have it up here, will look like that. The Lewis dot structure for oxygen will look like that. And so what we have going on is at least the best thing that we can do is start off just like we normally would and say that our nitrogen will bond together. And with that, we'll have a little there. It will have a non-bonding here, non-bonding here. And then we'll have those extra. that will be bonded to 1, 2, 3, 4. And then our oxygen would be placed there. Now I'm going to run out of room. And we get some pretty crazy things happening. It gets really crowded because I didn't draw it out very big or right. And we look at that and we go, that doesn't look right, because oxygen has this one single one by itself. Now we have a couple options that can happen. Sometimes what happens is these crazy things happen that this electron will come and will hang out over there. Or what I anticipate happening would be nitrogen forming multiple bonds with oxygen, and that we have there and there as one option as well. And this, I think, helps clean it up a little bit as well. And that we can see, maybe, where some of these dots go into. And we can see we should have 17, and so we do our counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So that would be a viable structure for us, and that would be one method to do it. There are others, and we will talk about how those work, and we'll get a little bit more together later on. But let's move on to the next one. Let's go on to one that's maybe just a little bit easier, and that's carbon, and one that is more ethane. And so what we have is we have more than one carbon. So we take our carbon and we're going to bond them together. Just how we have it. I have 6 hydrogen to place, as it would make sense to put them in the open spots around carbon, as we have there. Nope, missed one. And down there. And so, and if I look around each carbon, I would have a total of 8, because we now remember these two in the middle here are being shared by both. So it doesn't count, this pair here counts for both. On this next one, methanol, which is a very important compound for things here. We have our central atom. Now what gets to be interesting is the order that we have. Now this one's an order issue, because this oxygen we can see is not written first, and this hydrogen doesn't get pounded up with that. Now if I had that hydrogen there, it would be very similar to methane. But that hydrogen is kind of, the placement of that hydrogen is indicating that this hydrogen is not bonded to that carbon. Instead, this hydrogen is actually bonded to that oxygen, and which means I would then put my, I might have to resize this here. My carbon is going to be bonded to 3 hydrogen and then an oxygen. Now, the hydrogen are easy because there's 3 of them put together. Why does that oxygen fit there? Well, it does because that hydrogen that's written on the other side of oxygen is indicating that there is another hydrogen there, and it has to be bonded to something. And it's written on the other side of oxygen, indicating, based on the formula, that it's bonded and sharing electrons with oxygen. And so it has this weird looking form. And now using the dots is very beneficial so that we can see how these dots are being shared. We will eventually get to the point where we will kind of clean some of this stuff up and make it look a little bit nicer, but we do need to understand like where are some of these electrons being shared at.